طيب بسم الله الرحمن الرحيم. So I thought today is just to agree on the syllabus of the course, which is available on Blackboard. Of course, nobody has looked at it because you don't have access to Blackboard. But the first thing is that all the lectures are going to be recorded. As usual, this recording should be used as a reference for the students, but it's not as a replacement of attendance. So attendance has to be physical, face-to-face, unless there is an exemption, which there is an official forms that needs to be submitted for this. طبعا, my name is Amr Muhammad. I'm a professor in the department since 2007, and my area of specialty is not actually security per se. It's networking and communication. But as many people, they try to incorporate security aspects into networks and communication frequently. So the course is going to be on Sunday, Tuesday, and Thursday, but the office hour is going to be on Tuesday at 12, so right before the lecture. And of course, if this time, as usual, is not suitable for some students, they can always request a special office hour by email. So this is the course description, which we are not allowed to change. It's part of the catalog, but it kind of reflects the content of the course pretty much. So prior to this course, of course, there's course of applied cryptography, which is in one level before that course. So we'll try to build on this course. However, because we know the fact that, or we appreciate the fact that students might have forgotten some of the topics of this course. So in the first 1 or 2 weeks, we will we will try to, as much as possible, to review the applied cryptography, at least the important concepts as part of the applied cryptography course in the first 2 weeks. But we'll do it a little bit fast, assuming that students already have the background. Then we are going to talk about the security services in different layers. As a course coordinator, I actually suggested to go layer by layer following the TCP/IP stack of the network. Although the book is not going in order, as you will notice if you take a look at the book actually jumps between the layers when it comes to explaining the different security services. However, we will try to follow the networking stack layer by layer, and we will highlight which chapter we are going to cover at this point. I'm going to give more information about this. So the course prerequisites are applied cryptography and network 1, of course. So we assume that you have some background about these courses before coming to this course. So this is the textbook. It's not available at this point at the library, but I assume that you can get a PDF or something like this. So usually we cover the 6th edition of the book. So this book is by William Stallings. This book is for both applied cryptography and security services or network security. So the first 3 chapters or 4 chapters it actually covers the applied cryptography techniques in details, and then goes to the network security services in different layers. However, as I said, it doesn't go layer by layer. It jumps between layers, but we will try to go in order of the layers to abide or to follow the network 1 course. In addition to this, the second course, textbook is just for reference. And this book, provides more details when it comes to some network security services. However, this is optional. But as usual, the course textbook, we will try to follow the detailed information in this book. And the rule is, as I always say in my courses, whatever we discuss in class, even if it's not in the book, it will be part of the material, and whatever is in the book that's not discussed in class will not be part of the material, so you're not asked to know anything about these parts. So we are...
It's not in the library, nor the textbook section. The textbook.
Nor what?
From the textbook section. We cannot buy it from the textbook.
No, but you can always find the PDF. You can find the PDF. I personally, feel more comfortable using the PDF. I have the hard copy book, but it's for decoration of my library. But usually, I'm more comfortable using the PDF. I can search through the book easily. I can find all the material much more convenient. But some people, yes, they prefer or they like the hard copy book. So at some point it will be available in the library, but not as far as I know, not until today. So the course. So of course we will hand some class notes. We will hand some even research papers for those of you who are interested. But again, these are extra materials that they will not be part of the core materials of the class. So the course objective is to understand, analyze contemporary network security concepts, technology, and paradigms, which is related to network security in particular. So we'll talk about the difference between the normal information or computer security, which is the big umbrella, and what we mean by network security. So network security is part of information security, which is the big umbrella, but it has to do with security services that are part of communicating information between two entities. Okay, so information security is concerned with possibly like making sure that your virus detection is updated, the software that runs on the machine is vulnerability free or something like this. But as long as there is no communication, so network security is not part of this. So network security comes whenever you want to move information or data from one entity to another. That's when you have to have some network security services, and that's what's covered in this course. So in terms of course learning outcomes, so we need to understand and analyze network security essentials and the basic concepts. So I'm going to go in the first, 1 or 2 weeks, we're going to go through some basic definitions of some basic concepts. What are the pillars of security in general? What is the difference between security mechanism and security service? Okay, so what are the famous security mechanisms which are part of applied cryptography course? We're going to highlight some of these mechanisms and talk about them in high-level point of view. Then the course is going to dig in details into network security services, layer by layer. So in for example, in the network access layer, what are the physical, because in network security, in network access, we have, of course, physical ports or logical ports in case of wireless. So what is the difference between securing physical port and securing logical port, like for the case of wireless? What are the famous security services in each of these parts? And then we're going to go through a network layer. Of course, we have IPsec. And transport layer, for example, we have transport layer security, or SSL. So we're going to go through all these protocols and services and analyze and characterize the main specifications of these protocols. Okay. Then we will try to learn some tools as we go along the material, and learning these tools will require some work from your side to try to learn some software libraries like OpenSSL, which you will have to use as part of the assignment, as well as some other tools which you will have to use as part of the course project, as we will see. Number 4 is to work in groups. Depending on the number, the group might be as simple as just one person, depending on the number. But if the number increases a little bit, then I personally prefer to have constant interaction with every single group in the course, in which case I try to keep the number of individual projects not more than 6 or 5, 5 or 6 projects, different projects. And usually I don't have one single project for all the class. No, I give the freedom to students or to different groups to define a set of objectives for the course project and highlight some deliverables, some specific deliverables as part of this project. I'm going to talk about this in more details. So these are the course learning outcomes. Of course, the mapping and stuff like that is part of IBIT, so you don't have to worry about it. Then these are the topics. These are the topics of the course. So, so the introductory part is part of applied cryptography. So in the first 2 weeks, we are going to discuss some security concepts, basic definitions, as I said. And then starting from this, we are going to go through network access control security. So network access control contains, of course, data link layer and physical layer, right? So this is network access layer. I hope you still remember. Huh? So network access control security is the first layer, which contains physical and data link layer. And we're going to go through the security protocols in this layer, okay? Then after this, of course, there is the wireless. Wireless is also a network access control, right? It contains the MAC and the physical layer, right? But for wireless, it's totally different because we don't have like physical ports or cables, right? We have logical ports, right? We have logical because it depends on wireless signal. So security protocols in wireless is very different compared to Ethernet or compared to cable-based security services. So we are going to talk about a full chapter for wireless network security. Then we're going to talk about IP security. The most famous one is IPsec. So what is IPsec? Why do we need to have security in the network layer if we have security from the network access layer? Why do we need to have security in every single layer? What are the characteristics of IPsec? What is the scope of this in terms of even routing messages? They need to be secure, things like that. Then we are going to go through transport layer security. And again, I mean, if we have IP security, why do we need transport layer security? So again, transport layer is concerned with application point to application point communication, right? So communication between two application endpoints, like client and server, right? So what are the security services that has to do with transport layer security? So then, by that time, we will have covered all the security services and all the common layers that we know about: network access layer, network layer, transport layer, and so on, and also application layer. Okay. Then we're going to go through system level security. So this intrusion detection systems is not concerned with a specific layer, but you can combine all the layers together. Like, for example, you can have like firewalls that combines some rules from the network layer, like IP address, and some rules from transport layer. So you need to have like a rule that contains both IP and port numbers and so on. So we call this we call this system level security. So it's not focused on one single layer, but it can combine all the layers.
So the intrusion detection system and firewalls are the same?
Well, they are related, but usually we talk about them differently. So intrusion detection system talks about the fact that we need to secure a system, okay, a full system, distributed system that contains like a network infrastructure and some servers, okay? So we need to secure that system. So where do we put the firewalls? Where do we put, like, for example, TLS? Where do we put IPsec? Yani, so we look at the system as a holistic unit, and then we need to secure that system. So we can secure that system in a centralized way, in which case we deal with that system as one unit, and any data or any traffic that comes to this system will have to go through one single centralized firewall that has to make sure that this traffic is really highly secure before it admits that traffic to the network. But there is a problem with this, of course, that every single traffic has to go through this point. So it's a single point of failure, and it has to be really confirmed that this is secure. Okay, but nowadays there is what they call distributed intrusion detection systems. So you look at the system as a distributed system, and similar to the distributed nature of the system, you also need to distribute the security services in that system. Okay, so as a system analyst or a system designer, where should you position the different security services in this system to make sure that all the parts of this system are secure from any kind of intrusion? Okay, so this is system level security, which in order to cover this, of course, we need to cover all the security services in every single layer before we can talk about this. Okay.
Sequentially, layer by layer.
Yes. So actually, you see here, this is the chapter number. So after talking about the introduction, we will jump to chapter 5. Okay, and then chapter 7, and then chapter 9, and then we'll go back to chapter 6. Okay, so we'll not necessarily follow the order of the book in terms of the chapter number. And this is because I taught this course before in the graduate level, and I thought that following the layers one by one is more, it helps the students visualize the security services much better. Okay, but that's not how the book is actually configured. So that's why as a course coordinator, I took that decision to jump between the chapter and make sure that the students understand that we're not going in order in terms of chapters. However, this will help you visualize the security services layer by layer, and what are the differences between providing security in this layer and this layer. Okay. Of course, student, actually, this firewalls, as we said here, is optional. That depends on the time. Okay, we're not sure, because this is the first time this course is offered. We're not sure if we'll ever get to this, and even the intrusion detection system. So this is the first time that this course is offered. So we'll always try to sense feedback from the students, whether it's explicit or implicit, to try to decide on these topics, and based on that, we adjust the topics accordingly. In the graduate level, by the way, we give all the details about applied cryptography and network security services. We give all, right? But for undergrad level course, I'm not sure if the students will be able to absorb, because if we do both, it will be very overwhelming for the students. So we'll go step by step and see how it goes, right? Based on that, we will adjust these topics accordingly. Okay. So feel free to interrupt whenever you have any questions. Okay, so access control security, is this going to be part of the final or not? We'll decide on that at the relevant time. Okay.
We skipped chapters 2, 3, 4. They're not important from the book.
2, 3, and 4, they cover the applied cryptography part. Okay, which we will cover, but we have one slide deck for all the applied cryptography part, which is going to be covered in the first 2 weeks. Okay. So usually we should not do this, assuming that students already have gone through the applied cryptography course, right? So we can jump directly to the network access control security, but we appreciate the fact that students mostly have, and some students they had actually some problems with the applied cryptography course, especially it's pretty intensive in terms of math and stuff like that. So we'll try to at least cover the concepts, the most important concepts, as part of the applied cryptography, because we'll build on that for the security services. So when I talk to you about, for example, the fact that TLS uses this mechanism of key exchange, so you should be familiar with this key exchange technique and what does it mean. Okay, so we'll try to give some idea about this in the first 2 weeks. Okay, before we can get to the network security services. Any other questions? So I was debating whether to get into the material, but obviously we don't have to do this today. So starting from Tuesday, inshallah, we can start with the introduction. And again, the introduction, it's very light. We will go through some basic definitions, and then we'll talk about the security mechanisms. Okay, in terms of providing confidentiality, integrity, and so on.
You mentioned that you will show us how to use some software tools, like in class.
Not in class. So we will provide some documentation. Like for example, in the assignment, part of the assignment will guide you through the documentation for OpenSSL. Okay, so it's usually straightforward, especially if you have some idea about programming and stuff like that, which we assume you all do. At a 400 level course, the assumption is that you have some programming skills, in which case you can really learn this on your own. But if needed, we can provide some tutorial about some other more advanced implementation-based tools, or if we get to, for example, like tools for hacking or something like this, we can provide some tutorial about this. But we will see how it goes, and depending also on the projects. So once all the groups they finalize the projects, we'll look at all the projects and see if there is like a common theme that we think that if we provide a tutorial about this aspect, students will be more clear and more familiar with what to do. Then we can do that. We can provide this tutorial. Okay. Any questions? Okay. Let's jump to the most important part of the course, which is the assessment. Okay. The assessment is very similar to all the other undergrad courses. So we have quizzes. So we will have on average 4 quizzes. Okay. Only 3 of them will count. Okay. The best 3 grades of these quizzes will count. The homework, there is one homework, and it's implementation based. So it's based on using the OpenSSL library, which is based on PHP and Python, and so it should be straightforward to most of the students. So we'll provide the documentation for the OpenSSL and some specification for the assignment and so on. So this assignment is also going to prepare you for the project, because the project is also implementation based. So you have to do some development as part of it. So it's not like a survey or reading some paper and summarize the paper. So I don't do this. Projects are always development based. So you have to develop something. You have to program something. So I'm going to talk about the project separately. The midterm, of course, is 25%, and the final is 30%.
Sorry for the interruption. The midterm is pretty late, I think, 22nd of March. We pretty much finished. Okay.
I think this is right before the spring break. We try to put it right before the start of the spring break.
Because then there's also.
Yes, but we try to put it right before, and we try to do it this way because after the spring break, usually it's very condensed with so many exams and stuff. So we'll try to do it before, just to avoid any contention here. So when it comes to the project, for the project, I already prepared the course, the project description. So the way that I usually run the project in any course is by having 3 milestones. Okay, so in the project we have 3 milestones. The first one, I call it project proposal. Okay, so in the project proposal, you will receive the project description, which is a full document that describes all the format of the project, and it gives you even some potential topics. Okay, some students, of course, they don't know how to start, or they don't know specific topics that. So I have a list of potential topics that you can read, and then you can select the one that appeals to you based on your preference. So from the title of the topic, you should get some keywords and then read about it more on Google. Okay? So for example, I need to design intrusion detection system using machine learning. Okay? So I get some keywords from that. I learn about intrusion detection systems, what are the components, what are the concepts of intrusion detection system, and how to use machine learning for this. That's an example. Okay? So in the proposal, you should have like a 1 page that contains a small description about what you plan to do and what are the objectives of the course project. Like, for example, you need to get familiar with what intrusion detection systems are, and you need to learn machine learning or use machine learning for securing intrusion detection systems, something like that. Or you need to get acquainted with what TLS is all about, transport layer security and or IP security or stuff like that, and then use IPsec مثلا to secure routing protocol مثلا in a network, something like this. Okay. So you will have a list of topics and then you select from. Of course, I advise most of the students to come and talk to me, and we can. So for example, you can approach me and say, okay, I'm thinking about doing this. Okay, so what do you advise? So we can put together like a scope, which is not like building a spaceship, because sometimes students they get motivated that they try to describe a scope that's not achievable. Okay, like for example, I want to modify the web pass security for wireless systems. Modify the security protocol. This is not achievable. It's not a course project. Okay, people spend years to come up with these security standards, and you want to modify them. Doesn't make sense, right? So through the discussion and through this interaction, we try to define together a reasonable scope that you can really, and I can give you some advice and some tools, I can give you some documentation, some papers, okay, that you can that can help you to try to know exactly what you are going to work on, okay. So this project proposal is usually due in the first month of the course, okay, during the first month. And of course, all of these milestones or phases are going to be posted on Blackboard as assignments. So there will be assignment, which is project phase 1, which is project proposal. Project phase 2. So in phase 2 of the project is going to be the detailed design. In the detailed design, you are expected to provide all the details, everything except the implementation part. So you are not be required to include in the report anything about the results. Okay. So for phase 2, I'm going to also provide like some template that you can use to write your paper and so on. What are the contents that I'm expecting in this paper? And then, of course, phase 3 is the final submission, the final project. And then the final project, of course, there will be like presentation and report and code or implementation, actual implementation. So all these three components are going to be part of the final. Why does it keep stopping? Okay, so so usually what we do is that we announce a deadline for the presentation, in which case all the groups are going to present their findings of the project with all the results and everything. And then few days after, we submit the final components of the project, which includes all these three components. Okay? So during these three phases, after each phase, I should provide some feedback. That's why I said, usually I try to keep the groups within 6 groups or something. So, so depending on the number, we may have to work in groups of 1 or 2. Next. So I provide a feedback in every single milestone. Based on that, I expect you to address these comments in the next phase. Okay, this is the main idea behind providing feedback in every single milestone. And that's why the component of the project is significant. And we were debating actually to make it even equivalent to the final, but we finally set it to 25%. So we expect the project to have a significant implementation component, programming component. But we'll not leave you completely. We'll provide some documentation, some material, and at some point, if needed, we can provide some tutorial as well about some tools. The project could be, and it's clear from the description, it could be a simulation-based project, okay, or actual implementation, okay. So, for example, you can provide like some security service for a drone-based communication. So you have a drone communicating with a base station, okay, and you can provide security services in this type of communication. That's a real implementation. So you will have an actual drone, and the drone is mobile and stuff, and make sure that, and then you will do some measurements, okay, about the secure communication. So for example, you can say, okay, so if I don't provide security, I can measure some throughput, some delay, something like that. And then if I provide security, what would be the overhead? So if I provide, like, for example, confidentiality and stuff like this, what would this add in terms of overhead, in terms of protocol overhead? Okay, so I can measure that overhead, okay, and provide the result before introducing the security service and after introducing the security service, okay. So this can be approached from an implementation point of view or from a simulation point of view. So I can have a simulation tool which simulates the fact that I have a drone, but it's modeled. It's not an actual drone. It's actually a model of a drone. Any node that moves, okay? Any node that moves. And then we have another node that's not mobile, it's fixed, okay? I don't have physical components in that case. I simulate the whole thing, okay? So the project can be implementation-based or simulation-based. Both are okay. And for each type, you can use, like, for example, a simulation tool like NS2, NS3. You can use open simulation. You can use or you can use actual tools using like software for the client, software for the server, and you can use OpenSSL library or any kind of security library or anything like that. So you have ultimate flexibility, okay? And usually that's a little bit tricky for the students, and that's why we need to have communication, okay? And try to scope it down and lock on a specific scope that's reasonable for you to achieve, okay? And we need to do that early on so that you have a good chance to realize or to approach that project from an implementation perspective, okay? I think that's pretty much it for the syllabus. Just one note, because of the current situation that we are in, if for any reason you need to attend online and you have some justifiable يعني, form or some approved form, you communicate that to me. Based on that, we are going to find a way to arrange for online. Of course, if I'm the person who have this problem, then the only way is to make it online. Okay? So I'm going to communicate to all the students and ask you to and send you some links to use for online class. Okay? I think that's pretty much it. If you have any questions, anything.
Is the final exam cumulative or comprehensive? I mean, comprehensive or just the second part? You haven't thought about it?
Well, again, this is the first time this course is offered, so I can simply tell you now it's comprehensive. So the result is half the students will drop the course. So, yeah, no, we don't have clear answer for this at the moment. So we are going to decide that in a later stage. In all cases, I don't think it's gonna include everything, because we have the quizzes, which is normally we use quizzes as a diagnostic assessment for small units of the course. Okay. The final exam is accumulative, right? But accumulative starting from what? Starting from where? That's the question now. Okay. And for that same reason, also we have the midterm. So usually the midterm covers the first 50%, and the final covers maybe 60, 70%. So we'll see. But I can tell you from now, for example, introduction part is definitely not part of the final. Yeah, the first 2 weeks are not going to be a part of the final exam. That's for sure. Okay. So starting from the third topic, which is